In problem 5.16, we're given two parametric equations given by formula 5.20, and we know that our spaceship is equals to pi over 2. So what we can do is plug in pi over 2 inside our equation. Okay? So let's rewrite y of t with a2 cosine of wt minus pi over 2. So now what I want to do is take x of 0 and y of 0. X of 0 is going to be equal to a1 cosine of w times 0. So it's going to be equal to 0. a1 cosine of 0, which is equal to 1. So it's equal to a1. And then our y0 will be equal to a2 cosine of wt, and t is 0, right, so minus pi over 2, which is equals to a2 cosine of negative pi over 2, which is which is 0. So a2 times 0, which is equal to 0. So if we're to graph this in x and y plane, you know that when t is equal to 0, x is going to be at the point x equals to a1 and y equals to 0. So this point here is a1. Now let's take another point and let's say y, x of, let's call it pi over 2 w, which is equals to, for a, is equals to a1 cosine of w times t, which is pi over 2 uh, uh, over 2 w, and then y at the same point, so pi over 2w is equals to a2 cosine of w times pi over 2w minus pi over 2. So from the first one, we obtained that the w cancel each other out, as well as the second one. But in the first one, we in the end we obtained pi over 2. And since we have cosine, we get 0. So the x will be 0. The second one instead will be a2 to the y cosine of pi over 2 minus pi over 2, which is of course 0. So a2 times cosine of 0, as that it's equals to 1, so we have a2. So when x equals to 0, we have y is equals to a2. So at this point right here, a2. Let's try another point now. Let's try x of pi over w. So we're going to have a1 cosine of w times t, which is pi over w, minus, and that's it. And then we have y of pi over w, which is equals to a2 cosine of pi w times pi over w minus pi over 2. So we're going to have, from the first one, a1 times, well, we're going to have, w cancel w, so cosine of pi, which is equals to 0, so 0. Cosine of pi is equals to negative 1, my bad, so negative 1. And then we're going to have, in the second one, we're going to have a2, and then cosine of what is left after that is a pi minus pi over 2, which is pi over, black, which is equals to pi over 2. And cosine of pi over 2 is 0, so we have 0. So now we have, when y is equal to 0, and we're going to have x equals to negative a1. So right here, negative a1. And then the last point we're going to do is going to be equals to x of 3 pi over 2w. So we'll have a1 cosine of w times 3 pi over w, and then y of 3 pi over 2w is equals to a1 cosine of w times 3 pi over 2w minus pi over 2. So from the first one, I'm going to have a 3 pi, sorry, 3 over 2 pi, what do I do, 2 over here? 3 over 2 pi, and cosine of 3 over 2 pi is equal to 0, so I'm going to have 0. And then for the y, we're going to have always canceling the y's. So we're going to have a1 times cosine of 3 over 2 pi minus pi over 2, which is equals to pi. So we're going to have negative a1. That's our a2, because we're talking about the y. So this a2, a2. So here's going to be a2. So if I were to actually find a point in this between, we're going a curve connects these points. Now, for me, I actually drew that a1 is equals to a2. But if I were to actually say that, for example, a2 is bigger than a1, then I would have to shift this point, a2, down over here, and then point up here, up. So I would have something like this, a2, negative a2 over here, and a2 over here. So I'm going to have, as you can see, an ellipse like given to us by book. And so we proved our point, our request. Now you can actually find points like over here, and since we know it's going to be equal to a cosine, of course it's going to be equal to a slightly curved values. So they're going to decrease non-linearly on this curve, like in every other curve. And there is a solution to our problem. This is an overview of what we did. That's the end of it.